I'm Miguel San Martin with Chula Vista Electric. I'm here to give you a small training about the PV system we install here at this facility. We're going to start with the meter. This meter is where it connects to the utility. From our meter, we connect to our main service disconnect right here. Every disconnect is labeled PV DP8. This will be an example on this one. It's a 480 volt system, 3-phase, 3-wire. The placard is telling us where it's being fed from. From the main breaker, we go to our air switch on this section of the board. This section, same as the main breaker, if it goes in the open position, is going to disconnect utility from the distribution board. These breakers control every inverter that is being supplied from this distribution board. In this case, we have 1, 2, 3, 4, 8 distribution boards and an extra breaker that this is controlling the meter cabinet. If we turn off any of these breakers, it will turn off the inverter, and we'll show that in a later part of the video. This is an 800 amp board. Everything is labeled according to the standards. In this map, the same as every single cabinet will show, it shows the location for each distribution board according to where the plan is on the whole building and the whole area. If the fire department needs to turn off anything in an emergency, disconnect any inverter from the distribution board and take it away from utility so nothing is going back on utility, either they turn off the air switch or they turn off the breaker. These panels are all located and there's placards showing where everything is in place. Now we're going to move on to the monitoring area. This is the monitoring cabinet. So every single inverter that goes through the breakers in the distribution board ends up being monitored here inside of this cabinet. So this cabinet is remotely monitored by the Schneider software, and every single current transformer that it was placed in each breaker in the distribution board is going to end up in this little circuit board. From here, it goes to the remote station and it can be remotely actually monitored through the program. If the monitor system is not getting any signal, this is the place to come and look first. Every distribution board that is on site will have a placard, and it'll have the name of the distribution board. It'll say it's a photovoltaic system, and it'll tell you if there's a main disconnect inside of them. Again, main disconnect means that if in an event of any emergency, we can turn off the main breaker and it will disconnect utility from our photovoltaic system. And that concludes this piece of gear. All right, this is the inverter. Let's talk about this. This is the connection between solar panels and our utility. Here we have our AC disconnect. This disconnect should be in the on position so it can sense that there's utility coming in and it can start producing and send it back. If we turn off that disconnect, the inverter will not see utility power, it will turn off. On every inverter, on the side of the AC, it'll have a placard. The placard is telling us where is being fed to what distribution board is going. And for example, this one is going inverter 1, distribution 3, DP3, and it's a 33 kilowatt system. There's 3 types of inverters, 3 sizes. We have a 33, a 50, and a 62. Physically, they're all the same size. It's just how much they're carrying each one. This one, the max it'll do is 33 kilowatts. The 50 will do 50 kilowatts. 62 will do 62 kilowatts. It's an SMA inverter. And we can see on the top that we have a grill. This grill for maintenance, it has to be clear of any debris or leaves, dust, dirt. If we can keep it clean, it'll help the inverter stay cool. The air flows from the bottom and it goes by convection all the way up. There's fans working, so we want to keep this clear. Each inverter has two conduits going in. One will be the AC. The AC conduit is protected with seal tight, connecting to the inverter for vibration purposes. And we can see here in the back, we have the DC. DC is the wiring that is coming from the panels. AC is going to our distribution board. Both of them are grounded. The DC is grounded via a hub. The AC has the ground inside of the conduit. This is protected. This is 480 volt side. And we have our DC side. We're looking at the opposite side of the AC disconnect. We have the DC disconnect here. When we activate that switch, when we turn it off, we're disconnecting the grid, the solar panels, from the inverter. So if there's anything producing, we'll turn it off. Nothing is going to go through inverter. Nothing is going to go back to our source. When we look here in these three windows, window on the left, on the DC side, if it's green, green means that the inverter is in working order. Red will say that it's a fault. If there is a fault, the only way to know what's going on with the inverter is we're going to have to connect via Wi-Fi, Bluetooth to a tablet. The tablet is already designated to the project, and we'll go through it. We'll go through the parameters. We'll open up the windows, and we can see the events. There's going to be a log of events, when it turned on, when it turned off. It'll also tell us how much it's producing, voltage, amperage, how the DC is doing, how many of the strings are working. If we have 10 strings, it'll give us a detail of all 10 strings. If there's 12, it's going to be 12. If one of them is not producing, that's the point that we can start looking into a little bit of troubleshooting. Why it's not producing? Well, on the left side, we have the connectors from the DC going into the inverter. If by any chance something got damaged, one got disconnected, one got ruptured, whatever it may be, the string is not going to produce. That with the tablet, when we log into it, every inverter has a password on each one, and the tablet that is going to be designated for the project already has all those passwords in. And it'll tell us inverter so-and-so. So in this case, this is inverter 1 from DP3. It'll log in, we get all the information, and we can start troubleshooting. If we need to do a software update, that's when we do it. We have to just connect to the tablet and request the software update. If we do that, it can take up to 45 minutes. If we want to reset it with a tablet, it'll take between 3 and 5 minutes to reset it, and then it'll go through the startup process that it takes 5 to 10 minutes. It is not recommended to open up any of the strings under load. You need a particular tool to determine from the inverter. Again, not recommended. It's good to do it at night when the panels are shut off. If we were to turn the disconnect, the DC disconnect off and the AC disconnect off, this inverter will shut down. When we turn it back on, it's going to go through its normal process. In case we have a shutdown of the building that we lost utility power, the inverters will disconnect. And when utility power is restored, all we got to do is just wait, and they'll restart by themselves. That's how they're programmed to do. If we want to test one, we would open up the breaker at the distribution board. That'll AC power will not be going into the inverter. The inverter will see loss of power, will turn off. We can open up the AC side, DC side, turn it back on, and they should restart the minute we provide power from utility. Any troubleshooting has to be done with a tablet. So we would have to connect, again, Bluetooth, and determine what fault it is and follow that path. Everything else, it should be physical. We can see if there's any damage on the cables, any damage, any obstructions on the ventilation, any of the disconnects are off or on. And that's just by visually seeing it. We recommend that you clean it up. Make sure nothing is blocking any of the airways. Cables are intact. The AC is not damaged. Conduit is not damaged. Nothing physically has hit or damaged the inverter on the outside. All that is physical. We can see it. We can get to it, look at it. But anything part of the programming, we need to be connected with a tablet. Well, distribution board. This is one of few on the roof. The distribution board has the same characteristics as the first one that we looked with the meter. Only this is only a distribution board. It's not a meter section. The meter is inside of the building. But we do have a main breaker here. It disconnects utility from the distribution board. So in case we have to shut down everything, we come here, we exercise the main breaker, it's gonna turn off. Each individual breaker, again, it's labeled per inverter. Inverter 1, DP4B, it's a 50 kilowatt. Every inverter has to have a main breaker on the distribution board to disconnect from utility. Everything matches, labeling on the breaker and labeling on the inverter. Distribution boards are on the roof, and they're all close to where the inverters are located. Again, every inverter has a map, and it tells you where it's located and what's serving. And that will be all for this distribution board. There's not much more to have. Again, we have a metering cabinet on the side of it. All the CTs connected to each breaker is going to be metered into the meter cabinet, and it's going to go through the program to the Schneider program. You can have access to it, read them all. Again, this is just for disconnecting purposes. If we were to service any of the inverters, we come here to turn off the AC side. That'll turn off the inverter. Then we can turn off the DC on the inverter, and we can service it, look into it, or we have to do a shutdown. What we have here is our PV modules. We have every module, one of these needs to be cleaned periodically just to avoid dirt buildup. You can see there's a little bit of dirt buildup on it, and all these are connected in series. We have several strings going to each inverter. Again, we're looking here for any cracks, any damage, try to keep them clean. Any damage on the structure shouldn't be damaged unless something foreign hits it. A rock comes flying, a tree branch, somebody slides, somebody drops a tool. There's not much to talk about these, not much we can do about them. If we have a broken string, we have to wait until nightfall just to avoid having any loads on the panels. Remember, as soon as they have light, these panels are producing. So there is potential if we were to disconnect any of the wiring, is DC going through it. The cables we try to protect them, they're under the panels. Again, if we're looking for signs of stress, anything that nature can throw at us, all the racking has been supported, everything has been in place, everything has been torqued. Basically, there's not much work we can do on them just to clean them up. And if something gets broken, it's troubleshooting. Again, if we lose one of these panels, the inverter will be able to record it. We can jump on the program, connect with a tablet to the inverter, and it'll tell us if a string is bad because there's a bad module. It will not be producing. We'll have all these throughout the whole project. The only difference between this system here on the roof and the ones on the carports is these are sitting on the roof on racking, and the ones on the carport is just a different racking. But the principle is all the same. It needs cleaning. There's not much we can do. Dirt, that's a force of nature. Rain will clean them up a little bit. I do not recommend hosing them every day because it can build minerals on it. When the water evaporates, it leaves a residue behind it. It's recommended to clean them quarterly or at least 3 times a year with demineralized water, just so we don't leave any residue. Aside from that, they should be self-sufficient. And that ends this. Just take a look at the racking, make sure there's no damages.